All right, ready to dive into something kind of mind-bending.
Always up for a challenge.
Great. So today it's quantum sprung, you know, quantum leap,
I see where we're going with this. That phrase gets thrown around a lot.
right? Any big change and it's like, bam, quantum leap. But we're going deeper today.
Deeper. How so?
Well, we found this article. It's by Yurgo Schneppat. He goes way back, like to the physics of it all.
Okay, back to the roots. I like it. Quantum mechanics can be pretty wild, though.
Absolutely. And that's what Schneppat's getting at, this idea of a quantum leap as a metaphor. It all started with, well, actual quantum leaps.
He really brings out the historical side of things, doesn't he?
Yeah, he even talks about Niels Bohr's atomic model. Early 20th century totally changed how we thought about atoms.
Oh, yeah. Bohr. Electrons and their specific energy levels, like rungs on a ladder, right?
Exactly. And get this, when an electron moves between levels, it doesn't just slide around, it jumps,
Yeah.
like a Sutter zap. That's the real quantum leap.
And that jump, it requires a precise burst of energy, a quantum, which was groundbreaking. Energy not as the smooth flow, but in these little packets.
So not a dimmer switch, more like flicking a light switch on and off.
Perfect analogy. So we've got these tiny leaps at the atomic level. But how did quantum sprung become this metaphor for like massive technological change?
That's what I love about Schneppat's article. He traces that evolution. It went from these super specific events in the atom to this idea of any huge sudden advancement.
And nowadays, anything that seems to break the mold, disrupt the usual pace of progress, that's the quantum leap.
Right. It's not just incremental steps anymore. It's like shattering expectations.
Yeah.
And he focuses on two big areas where this is happening: quantum computing and quantum communication.
Those are definitely hot topics right now. Not just sci-fi anymore, but becoming reality fast.
Okay, so let's start with quantum computing. We hear it's exponentially faster than our usual computers, but how? What's the magic behind it?
Well, get ready for some truly mind-bending stuff, because it all comes down to principles like uh, superposition.
Superposition.
Yeah, think of it like an electron spinning both clockwise and counterclockwise at the same time. It can be in multiple states simultaneously.
Whoa, okay, my brain's already doing backflips. But then there's entanglement, right?
Entanglement, that's a whole other level of weird. Imagine two coins, no matter how far apart, they always land on the same side when you flip them. Measure one, you instantly know the state of the other, even across galaxies.
That's crazy. But how does any of this translate into actual computing power? Like, how do you harness that weirdness to solve problems?
It's about exploiting these quantum properties to do calculations in a whole new way. Quantum computers can explore tons of possibilities all at once instead of one by one. Imagine trying every route through a maze simultaneously.
Okay, so they can basically tackle problems that would take our regular computers, like, billions of years.
Exactly. And that opens up insane possibilities, right? Especially for anything involving heavy-duty calculations, drug discovery, materials, science.
Game-changing stuff. But what about quantum communication? What's so special about that?
Schneppert really highlights the security angle there, because quantum communication uses, well, quantum mechanics to make basically unhackable channels.
Unhackable. How?
Imagine a message that self-destructs the second someone tries to peek at it. That's basically what happens. Any eavesdropping, and the message itself changes, alerting both the sender and the receiver.
Wow, sounds like something straight out of a spy movie.
Mm-hmm.
So we've got quantum computers doing these insane calculations and quantum communication keeping secrets safe. But how does this quantum sprung translate to the real world? Does Schneppat get into specific examples?
He does. He gets into some really cool applications, like medicine, for example. Schneppert talks about how quantum computing could revolutionize healthcare.
Okay, medicine. That's a big one. What kind of impact are we talking about?
Imagine being able to design drugs with, like, endpoint accuracy. Quantum computers could analyze the structures of molecules, how different drugs interact with specific genes even.
So it's not just about finding new drugs, but personalizing treatments.
Yeah, exactly. It's like having a virtual lab that can test how a drug will affect you before you even take it.
That's wild. But what about all those crazy complex calculations? How do quantum computers handle that so efficiently?
That's where superposition and entanglement come in. Instead of analyzing each possibility one by one, a quantum computer can explore tons of solutions at the same time.
Right, I remember us talking about that. So it basically speeds up the process exponentially.
Exactly. And that's not just medicine. Schneppert also mentions finance, logistics, All kinds of fields ripe for a quantum revolution.
It's mind-blowing to think about the potential.
Yeah.
But Schneepat also acknowledges that there are some pretty big challenges, right?
Of course. I mean, this is cutting edge stuff. One of the biggest hurdles is just the technical complexity. Building and running quantum computers, it's not easy.
What makes it so difficult?
Well, you need incredible precision. We're talking about manipulating individual atoms and photons. And that requires specialized equipment, super low temperatures.
So it's not like we can just plug in a quantum computer and hit go.
Not quite yet. It's a huge engineering challenge. And then there's the whole issue of unpredictability.
Oh, right. We talked about that. Those quantum leaps, they're not exactly deterministic, are they?
Nope. And that makes building reliable technology a real headache.
So how do we tame that randomness? How do we make this technology actually work in a predictable way?
Well, researchers are working on some really innovative solutions. One approach is error correction.
Error correction.
Yeah, basically, because these quantum systems are super sensitive to any kind of noise or interference. So scientists are developing these complex codes to detect and fix errors during calculations.
Like a spell checker for quantum computers.
It's a pretty good analogy. And it's absolutely essential for making quantum computing practical. Another promising avenue is hybrid systems, combining the strengths of quantum computers with our good old-fashioned classical computers.
So using each type of computer for what it does best. Interesting. But Schneepat goes beyond just the technology, doesn't he? He talks about how this quantum-sprung idea can impact how we think, how we view the world.
Absolutely. Because at its core, quantum mechanics challenges our classical intuitions. It forces us to accept uncertainty, to see that things can exist in multiple states, to recognize how everything is interconnected.
So it's not just about building faster computers, it's about changing our perspective. Like we need to upgrade our own mental operating systems.
I love that. Schneepat doesn't explicitly use the term consciousness, but he definitely hints at this idea. Embracing quantum principles can lead to a huge shift in how we understand the world.
So quantum sprung, it's not just a technological revolution, it's a call for a shift in thinking, moving beyond that binary deterministic view of things. But does Schneepat give us any practical advice on how to actually do that? Can we train our brains to be more quantum?
Well, he doesn't give us like a step-by-step guide or anything, but Schneepat does point to some interesting ideas. He talks about how we get stuck in these old ways of thinking, these classical models.
Like trying to force everything into neat little boxes.
Exactly. Trying to predict everything, make it all fit into our expectations. And that's where we get tripped up, according to Schneepat.
So it's about loosening our grip on those rigid ways of thinking, embracing the uncertainty that quantum mechanics shows us.
Yeah. And that's tough, right? To let go of the need to control, to know everything for sure.
Definitely not easy. Does Nepad have any suggestions for, like, how to actually do that?
He mentions things like mindfulness meditation. Learning to just observe your thoughts and feelings without judgment. That can help us get more comfortable with not knowing.
So instead of trying to control everything, just being open to possibilities.
Exactly. Cultivating curiosity rather than clinging to fixed beliefs.
It's like quantum mechanics is showing us that the universe is always changing, always in motion.
It's beautiful, isn't it? And I think that's a really key takeaway from Schneepat's whole exploration of Quantensprung. It's not just about technology, it's about a whole new way of relating to the world.
Recognizing that interconnectedness, embracing uncertainty, being open to all those possibilities.
And as Schneepat reminds us, this isn't just some abstract idea, this is a call to action. It's about all of us expanding our consciousness, questioning our assumptions, being open to new ways of seeing things.
Wow, yeah. That's powerful. This deep dive into Quantensprung has been incredible, from those tiny electron jumps all the way to how quantum computers could reshape our world.
And, of course, exploring how this concept can even change how we think about ourselves, about reality itself.
A huge thank you to Yorgo Schneepat for inspiring this conversation with his fantastic article. If anyone's interested in learning more, definitely check out his work.
And until next time, keep asking those questions, keep exploring, and keep embracing those quantum leaps wherever you find them.
Absolutely. Thanks for listening.